Download this code from codegive.com, link in the description below. Troubleshooting unexpected fault address errors when copying boltdb databases. Encountering an unexpected fault address error when trying to copy or back up a boltdb database can be incredibly frustrating. This error typically indicates a low-level issue related to memory access or file handling, and pinpointing the exact cause requires a systematic approach. This tutorial will provide a comprehensive guide to understanding the problem, diagnosing the root cause, and implementing robust solutions with code examples. Understanding the error. The unexpected fault address error, often seen in Go panics, typically arises from trying to access memory at an address that the program isn't allowed to touch. In the context of boltdb copying, this can happen due to 1. File corruption *. The source boltdb file might be corrupted, leading to incorrect file metadata or data structures. When the copying process attempts to read or interpret these corrupted structures, it can cause a panic with an unexpected fault address. 2. Concurrency issues *. If the source boltdb database is being actively written to while you're trying to copy it, concurrent access can lead to inconsistencies and corruption during the read operation for copying. 3. Operating system or hardware issues *. More rarely, memory errors, disk errors, or problems within the operating system can manifest as this kind of fault. 4. Bug in boltdb itself *. While unlikely with the mature status of boltdb, especially if you're on a reasonably up-to-date version, there could be an edge case bug in boltdb triggered by a specific data structure or operation. 5. Incorrect permissions *. The process copying the database might not have sufficient permissions to read the source file. 6. Memory pressure / resource exhaustion *. In rare cases, severe memory pressure on the system, or exhausting file descriptors, could interfere with the read/write operations during the copy. General diagnostic steps. Before diving into code, take these preliminary steps to rule out simple causes. 1. Check disk space *. Ensure you have enough free disk space on both the source and destination file systems. A full disk can easily lead to write errors and corruption. 2. Check file permissions *. Verify that the user/process executing the copy operation has read permissions on the source boltdb file and write permissions in the destination directory. 3. Run disk diagnostics *. Use your operating system's disk diagnostic tools, example FSCK on Linux/Mac OS, CHKDSK on Windows, to check for and repair file system errors. 4. Restart the system *. Sometimes, transient OS or hardware issues can be resolved with a simple reboot. 5. Check system logs *. Examine system logs, example /var/log/syslog on Linux, event viewer on Windows, for any relevant error messages around the time the copy operation failed. Code examples and solutions. Let's look at common code examples for copying boltdb databases and how to make them more robust. 1. Basic copy, naive implementation, prone to errors. This is the simplest approach, but it's the most vulnerable to the issues described above. Why this is problematic *. No locking *. It doesn't prevent writes to the source database while the copy is happening. No error handling during io.copy *. While it checks for errors before and after the io.copy operation, it doesn't handle potential intermittent errors during the copy. A brief network hiccup or temporary disk problem could corrupt the destination file. Not atomic *. The copy operation is not atomic. If the process is interrupted, example by a signal or crash, midway, you'll be left with a partially copied, potentially corrupted database. No checksum/verification *. No mechanism exists to verify that the destination database is an exact copy of the source. 2. Copy with boltdb view and update transactions, improved, but still not ideal for large databases. This example attempts to improve the copy process by using boltdb transactions to read all the data and then write it to the destination. This can work, but it's usually not recommended for large databases because it loads the entire database contents into memory. Why this might cause problems and limitations ****. Memory consumption ***. As mentioned, this approach loads the entire database into memory. If your database is very large, you could easily run out of memory, causing the unexpected fault address error, or a more explicit out-of-memory error. This is the primary reason why this approach is discouraged for large boltdb instances. Concurrency. Still, while this example attempts to mitigate concurrency by performing the read within a view transaction, it's still not foolproof. If the database is actively being written to, there's a small window where the data read during the view transaction could become inconsistent. While less likely than the naive file copy, it's still possible. 3. Using bolt.db.copy file, the recommended approach, with robust error handling and locking. boltdb provides a dedicated copy file method for safe and efficient database copying. This method handles locking and ensures a consistent copy, provided you take the necessary precautions. Key improvements and why this is the preferred approach bolt.db.copy file This method is specifically designed for copying boltdb databases and handles the underlying locking and consistency requirements. Read-only source database, bolt.open, src path, 0400, nil. This is the most important change. Opening the source database in read-only mode prevents any writes to the source database while the copy is in progress. This ensures a consistent snapshot and eliminates concurrency issues. Failing to do this is the most likely cause of unexpected fault address errors during copying. Error handling The code includes robust error handling at each step of the process, providing more informative error messages if something goes wrong. Directory creation The save copy file function ensures that the destination directory exists before attempting to create the backup file. Atomic operation, while copy file doesn't provide a perfect guarantee of atomicity in the face of system crashes, it does a good job of ensuring consistency by handling internal locking. Important considerations when using bolt.db.copy file. Read-only mode is crucial. As mentioned earlier, always open the source database in read-only mode, 0400, when using copy file. If you don't, concurrent writes can corrupt the copy process. Locking boltdb itself handles internal locking within the copy file method, so you generally don't need to implement additional locking mechanisms in your code. However, if you're integrating the copy process into a larger system with other potential database interactions, be mindful of potential deadlocks or contention. File system consistency Even with the internal locking mechanisms, underlying file system issues, example disk errors, network file system problems, can still potentially cause corruption during the copy. Regularly test your backup and restore processes to verify their integrity. Permissions Make sure the destination directory has appropriate write permissions for the user running the copying process. Large databases Copy file is generally efficient, but for extremely large databases, hundreds of gigabytes or terabytes, the copy process might still take a significant amount of time. Consider alternative backup strategies like incremental backups if minimizing downtime is critical. 4. Handling file corruption and verification. Even with the precautions above, file corruption can sometimes occur due to hardware errors, software bugs, or unexpected system events. Here's how to address this. Checksum verification. After copying the database, calculate a checksum, example using SHA-256, of both the source and destination files. Compare the checksums to ensure they match. This provides a high degree of confidence that the copy is accurate. boltdb integrity checks. Consider occasionally running boltdb's check function on the original database to proactively detect corruption before you even attempt to copy it. While check can detect some forms of corruption, it doesn't guarantee that the database is entirely free of issues. It's a good practice nonetheless. Redundancy. Implement a backup strategy with multiple backups stored in different locations. If one backup is corrupted, you'll have another one available. 5. Dealing with concurrency directly, if read-only mode is not feasible. In some rare situations, you might not be able to open the source database in read-only mode, example if your application architecture requires ongoing writes. In this case, you need to implement more sophisticated concurrency control mechanisms. Exclusive lock. Acquire an exclusive lock on the database file before starting the copy process. This will prevent other processes from writing to the database while you're copying it. Be very careful with this approach, as it can significantly impact the availability of your application. Use operating system level file locking primitives, example flock on Linux/Mac OS, lock file X on Windows. Snapshotting. Use operating system level snapshotting capabilities, if available, to create a consistent snapshot of the volume containing the boltdb database. This can be a very efficient way to create a consistent backup without blocking writes. Examples include LVM snapshots on Linux and Volume Shadow Copy Service, VSS, on Windows. Replication. If high availability and minimal downtime are critical, consider using boltdb's embedded key/value store as part of a larger distributed system with replication and failover capabilities. This moves the problem from a simple file copy to a more complex distributed data management challenge. Summary of recommendations. 1. Start with diagnostics. Check disk space, file permissions, and system logs. 2. Use bolt.db.copy file. This is the recommended method for copying boltdb databases. 3. Open the source database in read-only mode. 0400. This is crucial to prevent concurrency issues and unexpected fault address errors. 4. Implement error handling. Use fmt.error to wrap errors and provide informative error messages. 5. Calculate checksums. Verify the integrity of the copied database using checksums. 6. Consider file locking. Carefully, if read-only mode is not feasible, use operating system level file locking, but be aware of the potential impact on application availability. 7. Explore snapshotting or replication. For high availability, consider using operating system snapshotting or a distributed system with replication. 8. Regularly test your backups. Verify that you can successfully restore your databases from backups. By following these steps and carefully considering the potential causes of the unexpected fault address error, you can create robust and reliable backup procedures for your boltdb databases. Remember that data integrity is paramount, so invest time in thorough testing and verification.